This video looks at common data objects that you're going to utilize in R. So let's go under the assumption that we have some data. We have some numbers, we have some values, something that we want to store. And we're not necessarily going to at this point worry about reading it in from an external source, but just what kind of objects would we save our data into. And so there are 5 major types of data structures that you'll come across in R, and we're going to look at 4 of them. There's an atomic vector, which is just a one-dimensional vector. There's a matrix, which is the 2-dimensional form of that. And then we're going to skip the array, which is just an extension to more dimensions for the matrix. And we'll focus a lot on the data frame and a list. So a data frame is just a more flexible 2-dimensional object, and then a list is a super flexible 1-dimensional object. We'll actually see that data frames are a special case of a list as well. All right, so let's start with the most basic one, the atomic vector. So a vector is just going to be a set of elements that have some kind of ordering to it. So there's a first element, a second element, a third element, and so on. And so this is going to be one-dimensional, and the way to create a vector generally is just to use the C function, which says combine these 2 values, or these 3 values, or these 4 values, whatever, together. So for example, here in this first one, I'm combining the number 1, 3, 10, minus 20, and the square root of 2 into a vector. So that's what this notation is saying. C is the function. You use open brackets to start the arguments for the function. We're listing them, separating them by commas. We're going to store that into the object X. Okay. And then here, for the second one, we're doing combine these character strings together, cat, dog, bird, and floor. And so again, this is just specifying the ordering of these elements. So cat is first, dog is second, bird is third, floor is fourth. And again, we're storing these in objects, so they're not actually printing to the console or anything like that. But now what we can do is call them for later use. So I can now just type X into my console after running the above lines, and I get to see the output there. And one thing about R is that there's tons of different functions that you're going to use as you use R, and a lot of them are going to output things like a character vector or a numeric vector. So a really shorthand way to make a sequence would be 1:20. That would be a sequence of integers from 1 to 20. So this is just shorthand for creating that sequence. And then I'm just dividing that entire sequence by 20, so that's going to do element-wise division. So every one of those elements will be divided by 20, giving me, in the end, a sequence of values from 0 to 1, separated by 0.05. Sorry, starting at 0.05. A way to make a more involved sequence would be the actual sequence function itself. And so there are a couple different arguments to that function. There's the from argument, the to argument, and the by argument. There's also an each, which is an option as well. So this is saying from 1 to 10 by 2, and that outputs 1, 3, 5, 7, 9. So you might see here this notation, this bracket 1. This is saying that this is going to be a vector that's being outputted. This is the first element. This one here, as it dropped down, this is now the 15th element. Likewise, this is a vector. The first element is 1, and then second, third, fourth, continue on that line. There's a lot of different functions for doing random number generation as well. So you might run across creating random uniform values, for instance, using runif. And so this says I want 4 values with a min value of 0 and a max of 1. And so we end up getting a vector with 4 values that are randomly between 0 and 1. And so one thing that you're going to notice as you start to use R a little bit more is that functions are everywhere. Pretty much everything can be considered a function call in R. And so you need to be able to figure out how to use those functions. And the easiest way is to look at the help for the file using help and then specifying the function that you want within the help brackets. So you might run in your R console help seek or help runif. So let's go ahead and do that. And so here we are in RStudio. So now we can go help seq for the sequence function. And in RStudio it comes up here in this little pane. And so you can see that this function, first it gives you the description of what it does. So this is going to generate a sequence. It's a generic function, the default method. So really, you could specify a lot of different ways to use it, but the major way to use it, the default method, would be to specify a from argument, a to argument, and then a by argument. Okay? And so this is telling you which arguments there are, and if there's an equal sign next to that argument, that's a default value for that. So if you run sequence and you just give it a to argument of, say, 5, you're going to sequence from 1 to 5 by what you see here. Okay? So again, sequence and I do 2 equal 5 or 4, whatever, I get a sequence 1 to 5 because it's using the default values that you see to specify everything else. Now, you get more information about what those values represent and what they need to be in the function notation and arguments down here. So from and to need to be the starting and end values of the sequence, of course, and then by needs to be a number that is the increment of the sequence. So the arguments tell you exactly what the function is looking for those things. Details will usually tell you how it's doing things, so what's going on under the hood in some way, shape, or form. And then finally it'll give you value, which is usually what gets returned. And at the bottom of these, they always give you little examples. And for newer functions, they generally have a vignette that you would then go have a link to that you could go see other examples as well. Let's just take a quick glance at our uniform as well. So random uniform values, this is actually a help page for the 4 common functions that you use with a parametric distribution. So D, P, Q, and R for the CDF, PDF, a quantile, and then random number generation. And so there are 3 arguments to RUnif. There's the n, the number of values you want, the min and the max. So you can come down here to see n is the number of observations, min and max are the upper and lower limits of the uniform distribution. So again, these help files are going to be really useful. They're how we generally figure out how to use a function. Okay, so that's basically all we need to know at this point about atomic vectors. They are just a one-dimensional thing where you have an ordering, and everything within that vector needs to be of the same type. So either all numbers, all character strings, all logicals, that kind of thing. Now these are not generally going to be useful for your data because usually you have more than one variable that you want to care about with your data. So vectors tend to be thought of as making up, say, a matrix or a data frame. So each one of the columns would represent a vector. So they're really useful to know about. Really consider them like the building blocks for other data types. Okay, so now let's extend it to a 2-dimensional form, a matrix. So this is just a collection of vectors that are all of the same type. So either all numbers, all character strings, all logicals, etc. And they have the same length. So for instance, I could make 2 vectors here. So x I'm going to store, and this is another function in R, the rep function. So this is going to repeat something. So I'm saying repeat 0.2 6 times. So it's going to create a vector of 0.2, 0.2, 0.2, right? And then y, I'm just storing this random sequence of numbers I typed in. But notice that these are both going to be numeric, and they're both of length 6. And so there are functions to check these things, just to show you some of those. There's a whole class of is.dot functions. So is.dot functions are ways to do a Boolean test of whether something falls into a category. So in this case, is.numeric. So is the thing that I'm looking at, is it numberly? Right? There's not like a super great definition of numeric, but is it does it contain numbers, essentially? So for both of those return true. And then we could look at the length of those. So length is the function to look at how long a vector is. So I give it length x and y, those are both 6. So these 2 vectors, same type, same length, they could be put into a matrix, and we could look at them that way. So how do we create a matrix? Well, we can use the matrix function itself. So a matrix creates a matrix. We need to first give it the values that we want to fill the matrix with, and then we need to specify how many rows or columns or both that we want. So here we're specifying that I want 2 columns, and so in the end we have 12 total elements that we're giving it, and so it's going to then realize that, well, if you have 2 columns, 12 elements, it must have 6 rows. So R is doing a little bit of under the hood stuff there. But notice what we're doing here. We're combining together the x and y vector, right? So C puts together 2 things. So we're actually putting together the x object with the y object. They both happen to be numeric, so now the total thing that this would return would be a numeric vector of length 12. Right? And so there's a numeric vector of length 12. We're going to have 2 columns. By default, R will fill a matrix down a column. So it fills down the columns to start with. So the first 6 elements go down here, and the second 6 elements for the second column. And so if you want to look a little bit further, check out help for matrix. Read through the different arguments and the different things that you can specify for that. Okay, so again, there are different arguments that you can give to the matrix function. So we could say n row 2. So if I want to make this first row be the x vector, the second row be the y, I could say n row 2. Again, I have 12 elements, so it's going to figure out that I must want 6 columns. And then there's a by row equal option. So here I can do by row equal true, and rather than doing the default where it fills down columns first, it will actually fill across rows first. So it's going to use the first 6 elements for the row. The first 6 elements are the x vector, the x object. Of course, you can have character vectors as well, not just numeric ones. So here's 3 different character vectors. If you did is.character, just to show you that there is an is.character function, those would return true for all of them. And so now I could create a matrix, x, y, z being my elements that I'm going to put into it. And then I'm saying 3 rows. By default, it fills down the columns. So I'd get a matrix looking like that. All right, so matrices can be useful for data, but not generally as great as it could be, because we have this restriction that everything within the matrix needs to be of the same type. And so that's not great, because usually our data sets are going to have some variables that are descriptive and some variables that are numeric. So here's one called brand that is describing which brand. So this would be a character vector, or maybe you might think of it as a factor. We'll talk about that later. But we have that alongside these different numeric variables. And so if we put those all into a matrix, R is going to coerce them all the values to be character values, because it requires everything to be of the same type, and it doesn't know how to create that brand as a number. It knows how to take 14.1, for instance, that you see here, and convert that to a string, just put quotes around it. But generally speaking, this is not going to be the best object to deal with data. So what is a great object for data? Well, it's the data frame. Okay? So a data frame is just a collection of vectors of the same length. So they don't have to be of the same type anymore. We've sort of relaxed that restriction. So for instance, I can take this x, this y, and this z, all of length 6, first one being character, the next 2 being numeric. And what we can do is just use this data.frame function, give the different columns that we want. So here I'm saying x is my first column, y is my second, and z is my third. And we output this lovely data frame that you see below. You can also change the names of your columns as you create your data frame. So if you specify a name here on the left, that is actually going to name that column char. Data 1 would be the name of the second column, and data 2 would be the name of the third. And then we're actually saying char should correspond to x object, data 1 y, and data 2 z. So that's really useful, because we're going to see that we're going to be able to access the different columns of the matrix, of the data frame, using these column names as we go. Okay, so again, data frames are the object that you're going to work with the most for data sets. Usually the number of rows represents the number of observations you have, and the number of columns represents the number of variables that you have. And so that's great for almost every data set that you're going to deal with. And so when we read things in from external files, generally speaking, they're going to go into a data frame. All right, last type of common R object that you're going to run across is what we call a list. And a list is one-dimensional, but it's super, super flexible. So it's one-dimensional in the sense that it has an ordering. There's a first thing, a second thing, a third thing. But it's so flexible that you could put whatever you want in the first element. So I could put a matrix in the first element, a vector in the second, a data frame in the third. I could put another list in the fourth, and so on and so forth. So you can basically put whatever you want in each element of this list. So how do you create a list? Well, there's the list function that will do that for you, and essentially you just want to give it the different list elements separated by commas. So the first thing I'm giving it is the quoted string hi, and so quoted string hi, if you just ran that, would return a vector of length 1 that just has hi in it. And so our first list element, so this here, this double bracket notation, this is saying the first list element is a vector with the value hi in it. The second list element we're saying is the sequence 1, 2, 3. So this is the second list element, has this vector 1, 2, 3 in it. R norm, just like R unif, is going to randomly generate 2 random values from the normal distribution, in this case 2 of them. So the third element for the list is a vector of length 2. And then the fourth is that character vector of those 2 punctuation marks. So again, these are just super, super flexible one-dimensional things. They have an ordering, but basically everything, every one of those elements can be of a different type, can be a different thing. And so when you start dealing with really, really complex data that doesn't sort of fall into that observations variables format, lists are really wonderful. So here's a little recap and review. If you're dealing with one-dimensional, you're probably in atomic vector or list form. And so atomic vector just means that everything within there needs to be of the same type, so homogeneous. And then a list can be heterogeneous. You can have a vector in the first one, matrix in the second. If you're in the two-dimensional, if everything's the same, you're in a matrix. And if everything's different, or if things can be different, you're in a data frame. Okay. So again, these are the most common types of R objects that you're going to run across for storing data. What we'll do next is we'll look at how we actually go in and extract different pieces of those R objects.